Welcome students to the module on pointers. In this module, I would like to introduce to you some of the basic concepts about pointers. Pointers are considered to be one of the most important topics in C, as well as by some as the most difficult to understand also. The first thing that we need to discuss about pointers or note about pointers is that they deal with addresses or memory addresses. All of us know that all the variables that we declare inside our C programs are actually allocated memory inside the random access memory. If you can visualize the random access memory as an array of bytes, each box here, take it as a byte, like that. Of course, there could be millions of such bytes depending on the size of the RAM. So these are all bytes here. Each one is a byte. It is called byte addressable. Memory. Addresses will be as numbers 0, 1, 2, 3, 4, like that. Maybe any number. I will just put 1 lakh here or 999, whatever the number. That is not very important. So all bytes have addresses which are simply numbers. So you can say 9th byte or 10th byte or 2000th byte or 99,000th byte. So this is how you address the bytes. Now, as all of us know, when we declare a variable in our programs, each data type variable occupies certain space depending on the system. So ANSI C specifies that an integer variable has to be given a minimum of 2 bytes. So this is the minimum. Maximum can be 4 or 8 bytes also, but most systems they give 2 or 4 bytes of storage. So assume that in a given system the integer variable occupies 2 bytes in the random access memory somewhere. So where is that? It has to be a specific location. So it could be the 3rd and 4th bytes. So where is this A located now? Or in other words, what is the address of A? Address of A is taken as 3. The starting bytes number. 3 means it will occupy 3 and 4 because integer occupies 2 bytes. Starting address is the byte number 3. So obviously 3 and the next byte also will be occupied. In the same way, if you declare a variable called D, and in a given system if you assume that float variable occupies 4 bytes, again those bytes have to be given somewhere in the random access memory. It could be the 4, let us say 6th, 7th, 8th and 9th, that is these bytes, 4 bytes. So that would be referred to as. So where is the variable D located in the random access memory? In the bytes starting from 6, 7, 8, or sorry, you can say 7, 8, 9 and 10. So the bytes 7, 8, 9 and 10 have been used to accommodate this variable D. So what is the address of this variable? We say that 7. Here the address is 3. So what is 3 and 7 here? 3 is nothing but the byte number. 7 is not, the 7th byte is the address of D. 3rd byte is the address of A. So there are situations, various situations wherein in our programs we need to deal with addresses. So, in order to deal with addresses, C has introduced the notion of pointers. Pointers are nothing but variables, so which can store addresses as values. We know that if integer a is declared like this, we can store an integer value inside. Now, just let us look at a new kind of declaration here. Let us say that I have declared these two declarations. Let's take this out. And somewhere B is allocated. Let us say this is the 20th and 21st bytes. A has been given a value of 10, and of course, a bit pattern corresponding to the value 20 would be stored in these 2 bytes starting at 20. That is the situation. Now, look at this declaration carefully. Look at the star here, P. So, this is how you declare a pointer. So, whenever you see a declaration like that, if I ask you what is P, P is a pointer. Star will always denote a pointer whenever it is declared like that. Star also is used for multiplication and other uses also. But right now here it is used to declare P as a pointer to int. Means that, simply put, now the variable P can store the address of an integer variable. Meaning I already have A and B as integer variables. They have some addresses. So, their address of A or address of B can be stored in P, which very simply means once I have declared P to be a pointer variable, so this can be thought of as a pointer variable or address variable, meaning that now what can I store in P? That is the question mark. We already mentioned that P stores addresses. And which address here? P is an integer pointer, so it can store the address of an integer variable. And we use the ampersand to take the address. It is called the address of operator. So, ampersand is also known as address of operator. So, when you write like this, look at the statement. So, what are we assigning to P? The right hand side is simply address of A. So, what is address of A? Internally it could be something, but let us for discussion sake you can take it as 3. So, that address, in whatever way the system deals with, that address is now assigned to P. So, if you can think of P as some pointer, now we say it points to, look at the arrow. Pointer is always something which shows you the direction. So, what is P now? P is a variable which is holding the address. P knows where A is. P knows the address of A because it holds the address of A. So, in a way, if this is P, it is pointing to A. You could write like that the next statement. Then the address or the value in P will change now. It will not point to A anymore, but now it will because it is a variable, we can put the address of any integer variable in P. So, right now that is the situation. P is pointing to B, that is P is holding the address of the variable B. Now, look at a couple of statements that I am going to write here. This statement here will simply put the value 40 into B, because when P is pointing to B, star P same as B. So wherever we use B, now we can use star P, because now P is pointing to B. That is, this is equivalent to writing the statement as B is equal to 40. So whether we write star P is equal to 40 or B is equal to 40, it is the same. So wherever we use B, star P can be used. Star P means the value at the address pointed to by P. So here the star is known as dereferencing operator. And also same thing we can say that A is equal to star P. This is again same as writing A is equal to B. That is, this statement when executed, 40 is put into star P is nothing but B, because P is right now pointing to B. So this 20 would become 40 because of this statement, and because of this statement again star P means nothing but this is equivalent to this. Put the value at B into A. So what is the value at B now? 40. 40 gets copied into A. So A also will be made as 40 here. So the moral of the story, what we are trying to tell you here is that once a link is established between a pointer and a variable, if P is pointing to a particular variable, star P simply is a synonym for the name of the variable. Star P means B in this case. And that star P can be used either on the left hand side of the equation or on the right hand side of the equation. Just like we use B, the name of the variable, either on the left hand side of the assignment operator or on the right hand side of the operator. So here we have learnt very simply what pointers are. They are variables. How to declare them? This is how to declare them. We can declare a pointer of other types also. For example, if you are dealing with floating point variables, you could simply declare them as, for example, when you declare like that, you can declare like this, any type. So C is a pointer which can point or hold the address of a character. P is a pointer here which can hold the address of a floating point variable, so on and so forth. So that is the syntax of declaring a pointer variable, and having declared a variable, we need to put values into it. So what are the values that you put into a pointer variable? Addresses. But then how do you obtain addresses of something? Using the ampersand operator, which we refer to as the address of operator. So you have to apply the ampersand to a variable, integer variable like this. So that address of A will now be put into P, which is a pointer variable. Next we can go on doing that, because pointer variable, it can hold the address of any variable. You can change that. And once you assign the address of a variable to a pointer, that you once you establish, if you can visualize it like this, once the link is established, right now it is pointing to B. So wherever we generally use B, in place of that, now we can use star P. So in this case, the star operator, which is the same as declaring here, it does a different job here. When it is used like this, it is known as the dereferencing operator, or sometimes known as indirection operator. indirection indirection operator or the dereferencing operator, because it takes the pointer and returns the value at that particular address. So when you want to obtain the value at the address pointed to by a pointer, we simply put a star in front of the pointer variable, you get the value. Just p will give you the address, star p will give you the value. So that's what I have tried to explain to you here. So the same concepts will be reinforced if you can just see a very simple program here. With that, let us try to understand pointers a little better. I want you to notice the prototype here. Immediately I am going to write a function whose name is swap, does not return anything, I put a void in front, and it requires 2 arguments and each one of them is a pointer variable. That is, when you call the swap function, what should we supply this function? 2 things. And what are those 2 things? 2 addresses. What addresses? Addresses of integer variables. So when you send the addresses of integer variables, those will be stored in P and Q. So that is the meaning. So whenever we look at a function, this is what we have to clearly understand. Now in the main function, we will simply swapping is simply you have 2 values in 2 variables. Swapping should exchange the values. For example, what we mean by that is, if we have 2 variables A and B, and in A there is 10 and in B there is 20 to begin with, after swapping, A must contain the value 20, that is, this value should be here, and B must contain 10. Exchange. So that is what we want our function swap to accomplish. So let us quickly see how it is done. In the main function, we will simply put the values in A and B, call the swap function, and the swap function is supposed to do the swapping. I want you to carefully look at the program here. It consists of one main function and a swap function, and swap function I have just described. It requires two inputs which are nothing but integer pointers, meaning two addresses of two integers. When you send that, it is going to try to swap the values. Now let us take line by line as we usually do and see how the program accomplishes the task at hand. I will just draw a line here to separate the two functions. We see that when the main function begins to execute, first variable A is allocated memory, value of 10 is put inside, and then we have B and the value of 20 is put inside because of this line here. Immediately this statement gets executed. So when the printf statement is executed, the values in A and B, the current values in A and B are printed. So I think this is what is expected as it is A and B. So 10 and 20. So that would be displayed on the screen because of the statement here. Then the control goes down and there is a function call. So this is where we have to understand clearly what happens. At the function call, we all know that the control jumps here, and as the control jumps, now before going to the jump or taking the jump, let us look at the arguments here, actual arguments. Swap function call is now made with ampersand A comma ampersand B. What do they signify? Read it in English. Ampersand is nothing but address of. So what is the first argument here? Address of A. What is the second argument? Address of B. You are sending them there. Where do you store addresses? In pointers. Do you have pointers waiting there? Yes. P is a pointer, Q is a pointer, waiting to receive these addresses. So it is simply equivalent to like this, writing int star P is equal to ampersand A. Int star Q is equal to ampersand B. So that is what going to happen now. Address of A is being sent and it will be stored in P. Address of B is being sent and being stored in Q. So P is pointing to which now? Because it stores the address of A, P will point to A and Q will point to B. So we can now say that if you can imagine this P and Q as pointers declared on this side here, P here, Q here. P will now point to A once the function is called, because P will now hold the address of A. Q will now point to B because Q has been assigned the value of address of B, that is goes there and gets stored in Q. So Q and P, now you see the link between the two functions. Actually the memory locations of the main function variables has been given to the pointer variables of the swap function. So once it comes here, int temp, there is no pointers here, please make a note of that. Temp is a normal integer variable. So temp is here, another variable. Next statement, what is the value that is put into temp? On the right hand side we have star P. What is star P? It's nothing but, for that we must know what is P pointing to. So right now we know that P is pointing to A. So star P is the dereferencing operator is being used. Star P is nothing but the value at A, which is 10. So with this statement here, star P is synonymous with A because P is pointing to A. So, in temp the value at A, which is 10, gets copied. So, this is as good as writing temp is equal to A, because P is pointing to A. Next line, star P is equal to star. So, this can be simply thought of, I will just draw one more line here. They are equivalent to saying temp is equal to A is equal to B is equal to temp. Think about it. From whatever little we have learnt, once we make a connection between a pointer and a variable, if the pointer is P, star P will give you the value, or it is synonymous with the name of the variable. P points to A means star P can be used just as A. Star Q is nothing but B. So, this thing can be thought of as equivalent to this. So, when this transfer takes place, let us see what happens. Temp is equal to star P, which is 10. A is equal to B. Star P is equal to star Q. What does that happen? This is nothing but A is equal to B. So, it is nothing but B gets copied into A. So, B gets copied into A. Because of the statement. And then star Q means what? Nothing but B. It is as if saying B is equal to temp. So, B is this memory location. Into that the value in temp gets copied, which is nothing but 10 here. So, the most significant thing that you have to understand in this particular program is that the memory values or the values in the memory locations belonging to the main function were manipulated by the called function, because you send the addresses. Once the function has addresses available, it can manipulate the original values. So, it comes here, end of the function, comes back. So, all executed, comes back, and then goes down. Again printf. Now, what are the values in A and B? You notice that because of the function call, that function call has actually changed the values. Now, when the printf statement is executed, the current values are printed. What is the value in A? It says 20. What is the value in B? It says 10. So, the printf statement will result in an output like this. So, what we have to understand here is that we are dealing with addresses, and through addresses we are trying to access the values, and the usage of pointers is most significant or useful whenever, of course, functions are involved. So, using addresses we are able to access the original values and manipulate them. So, here some operators are involved. The notation can be a little confusing sometimes. So, that is where we need to spend some time on. Star operator is used for various purposes, as you have seen. It does, in this particular point, it is declaring P as a pointer. Here it is being used as a dereferencing operator. That is one thing that we have to learn. And then when we are dealing with addresses, the use of ampersand is quite frequent. So, that also you must understand, that whenever we put that ampersand before a variable, we are actually, the result is nothing but the address. So, address of operator we have to become familiar with. When to use, that also should be clear to you. Obviously, whenever you want to put a value into a pointer, it has to be an address, and to get an address we use the ampersand operator. So, if you can remember the basic principles that are involved, that we remember that pointers variables are basically used to deal with memory addresses, and ultimately we are interested in the values at the addresses, and to get the address we use the dereferencing operator. So, if you can put all these things together, if you can clearly understand this very simple program, starting from the declaration of the function, starting from the main thing is the function call, see that there are addresses of A and address of B, and corresponding pointers are being declared there. Once received, how we actually access the original values using the dereferencing operators. So, if you can all put these things together, I am sure the basic understanding of how pointers are actually used will be clear. Now, let us try to look at the relationship between pointers and arrays. The first line, when you see, you can see that I am declaring an array, integer array of size 5, and I am initializing the values. So, this would result like this: 10, 20, 30, 40 and 50, and we already know how to refer to each one of these cells. If I want to refer to this, I would be saying it as, in my program, A of 0, A square brackets 1, A square brackets 2, A square brackets 3 and A square bracket 4. That is the usual notation we use. Now, I would like to tell you a new thing. What I mean by that is, the name of an array, which is A here, just A, not A0 or A1 or just A. The name of an array is a constant pointer to the first element of the array. Coming again, the name of an array, if you think of A like that, it is a constant pointer, that is, it points to the first element of the array, that is, it holds the address of the first element of the array. What is the first element of the array? A of 0. So, it is simply A is nothing but address of first element, which is A of 0. So, A being a pointer, just look at these couple of lines here. This line declares P as a pointer, integer pointer, meaning that P being a pointer of integer type, what can you put inside P? What can you assign P? We can put a address of an integer variable in P. And what is A? A is exactly that. By definition, the name of an array A happens to be a pointer to an integer value. A of 0 is an integer value. So, when you assign like that, you are declaring one more variable P here, that also is pointing to the first element. Now, both are pointing to the first element of the array. Now, just if you look at a small notation I wanted to introduce here, once this setup is made, once this statement are made, okay, P pointing to the first element. If I say in my programs P plus 1, so P plus 1 will refer to the next element. That is, if I say P plus 1, P plus 1 will, P plus 2 will point to this, P plus 3, this is P plus 4. So, once we have a pointer pointing to some element, plus 1, plus 2 will always point to the next element, next element, next element, so on and so forth. P plus 2 means second element after P. Plus 3 means third element after P. So, so on and so forth. So, once P is an address, P plus 1, P plus 2, P plus 3, P plus 4, simply they will denote the next element, next element, next element, so on and so forth. Okay. And if I say, for example, let us say I have one more pointer here. Now, if I say Q is equal to P plus 2. What would that do? One more pointer which is called as Q. What is the value that is being put inside? P plus 2. What is P? P is holding the address of the first element. What is plus P plus 2? This is the address P plus 1. This is P plus 2. So, P plus 2 is nothing but Q will now point to the second element of the array. So, that would be the situation. So, now Q plus 1, Q is pointing here. So, this would be Q plus 1. This would be Q plus 2. So, that is very simple idea. Once a pointer is pointing to some element, plus 1 will take you to the next element, plus 2 will take you 2 elements before. Same way, I can also show Q minus 1, I can refer to. Once Q is pointing here, Q minus 1 would refer to one element before. Q minus 2 would refer to 2 elements before, so on and so forth. So, within an array, once you get the address of one element, you can move back and forth just by adding plus 1 or plus 2 or plus 3 or subtracting minus 1, minus 2, minus 3. So, you can always go within the array once you have a pointer inside to the next elements or previous elements by adding or subtracting integers. So, that is what I am trying to explain here. And once you have the pointers, for example, here let us just stick with this A here, and then we had P, both are pointing here. Now, how do I access the values? For example, if you are using P, this is pointed to by P plus 1. What is P plus 1? P plus 1 gives me the address of this cell, but I want to address or get 20. All we need to do is, we say, for example, I declare one more integer variable. I say B is equal to star of P plus 2, for example. What could that possibly mean? Look at the both sides. What is B? B is an integer variable. What should be on the right hand side? Should also be an integer value. But is it? See, what is in the brackets? P plus 2. What is P? P is an address. Right now it is pointing to the first element. P plus 2 means this is plus 1 plus 2. So, P plus 2 is the address of this element here. But now I want 30. How do I get 30 from P plus 2? We already know that we need to use the indirection operator, the star. Put the star in front of the address, you get the value. So, this is nothing but 30 will be assigned to B. So, if you have a variable B somewhere, now 30 gets into it. So, this is how we actually reference or use pointers. Okay. So, once we know an address into an array, we can get the other addresses by simply adding plus 1, plus 2, plus 3 or subtracting minus 1, minus 2, minus 3 addresses. But once you have the address, we can also get the value by simply putting a star. So, when you have an address, if you put a star in front, you get the value at that particular address. So, that is the point that I was trying to make here. So, the pointers and arrays are very, very closely related. Just like I just said a few moments back, the name of an array is special. It is a constant pointer to the first element of the array. So, name of an array is a pointer, that is one thing. It is an address. So, having said that, once you have an array, so this is how you reference. So, in a way, we can also say that to conclude, when you are dealing with arrays, pointers and arrays, there is a common similar notation which I would like to share with you. A of 0, this is how we reference. So on and so forth. So, this is nothing but I want you to notice that the dash here simply relates these two. A of 0 is the same as, let me just take this out. A of 0 is the same as star of A plus 0. A square brackets 1 is the same as A plus 1 in front star. Wherever you can use this, we can now use the pointer notation. If you want, you can just check it out with the previous array programs that you have written, one dimensional arrays. Wherever we use A of 2, we can now use star of A plus 2. So now, in the same way, I would like to denote, this is simply A plus 0, address of A of 1. Address of A of 1 is simply A plus 1. Address of A plus 2 is simply A plus 2, so on and so forth. So, wherever we were giving notation like that, especially in the scanf statements, all you need to give is, so this is an address, this is also an address, because A is an address. Once the address is there, we just add integers to refer to the next element, so on and so forth. So, please think about that. So, we can conclude by saying that pointers are basically address variables. Pointers are used to store addresses. Various different types of pointers can be declared, of integer type or float type or anything like that. So, whenever you declare a pointer of some particular type, it can hold the address of only the similar type of same type of variables. Integer pointer can hold only integer address of integer variables. A floating point or float type of pointer can hold only the address of floating point variables, so on and so forth. So, pointers are basically used to deal with addresses, and we use the dereferencing operator, the star operator, to get the value at that address. And also pointers can be sent as arguments to functions, and by doing that we can actually manipulate the values in the original function. That also we have learned. And pointers and arrays are very closely related, because the name of an array is a pointer, constant pointer to the first element of the array, and because of that all this notation can be used. So, what we can do is, you can rewrite some of the small matrix addition programs and things like that. Just change the notation. Wherever we are using this, or A of I, just simply star of A plus I. Wherever you are using the address notation like that, especially in the scanf statements, just use this thing, A plus I. A of ith. For example, if you can, so generally you can say, wherever this is used, you can simply use A plus I. So, wherever we are using this notation, we can simply use, so we can say that in conclusion. So, think about that, read up a little bit on pointers. That should help your understanding of pointers better. We will have one more module on pointers, wherein we are going to learn some other aspects of pointers. Thank you.